This is the second part to our self-driving cars presentation. My name's Olivia and I'll be talking about the goals of the experiment. So, these researchers wanted to create a cognitive model with attention, which is just the technology that will allow the self-driving car to operate. This will allow the car to sense, plan, and control all at the same time while also accepting external control inputs, which the other methods of producing self-driving cars that their technology currently cannot do. So first, this technology will process road images with convolutional neural networks. These neural networks will analyze the visual imagery of the scene, and it'll help to create a cognitive map similarly to a human's visual cortex, which can be seen in this part of the diagram that I have here. So there's the input images, and then here's the convolutional neural network, which goes into making the cognitive map. So then next, they will use recurrent neural networks, which models sequencing data and temporal information of the motion control. And this also will combine with past knowledge of motion states, which will work to mimic the motor cortex. So then all of this planning and control strategy with the RNNs, the recurrent neural networks, outputs the control commands of the self-driving car.
To achieve the goals made by the creators of this new and improved model of self-driving cars, the writers began by designing a way to establish a cognitive map of the driving scene. The cognitive map depends heavily on perception of the environment. They did this through the use of 3 cameras placed around the car to record the scene of the car's current lane and lanes on either side of it. The data collected from these cameras are then shoveled into multiple convolutional neural network layers for processing and extracting road information. The processing involves many calculations to ensure the information is correctly incorporated and applied. Their next step was to create somewhat of a pre-existing database of various road conditions to train the car and test the model's efficacy. Drivers were recorded and asked to drive on different types of roads under a variety of light and weather conditions, as well as perform regular driving tasks such as changing lanes or making a turn. The collected driving scene information was not only used to capture safe and correct driving, but was transformed to create quote-unquote error states of driving. This special feature of the model will teach the car how to react to situations where the driving laws are not strictly followed, as routinely occurs when humans are driving.
Visual data and visual data augmentation. Generating descriptions of road scenarios requires a large amount of image data, and therefore it's difficult to encompass all of the possible situations that a self-driving car may see when on the road. And because of that, they can't record images from just the driver's viewpoint. So what companies have been doing is they use 3 different cameras to get 3 different viewpoints, and then they merge all of the videos from those 3 cameras into one, so it's more of a realistic view, including just like straightforward vision and then peripheral vision. And then the effects of multiple CNNs in constructing cognitive maps. So in a vision-based self-driving car, the precision of the surrounding environment perceived by the visual module is of particular importance because the perception results directly affect planning and control. And in most self-driving scenarios, the main indicators comprise the detection of free space, the current and adjacent lanes, and obstacle vehicles. So therefore, companies mainly evaluate the models by detecting these items. And as you can see in the image on the right, that's what the free space detection shows, and that's kind of how companies view everything.
So section B of the results states that in the study simulator, the car model interacted with road conditions and their states were sent to the internal controller as inputs to simulate human driving behavior in order to generate control sequences for adjusting attitudes of the car. During the study, researchers randomly placed obstructions or objects in front of the car at different distances to test how well it could change lanes and how quickly. Results of the study found that the self-driving car operation was similar to that of operation by human drivers. and so researchers were able to conclude that the self-driving car was in fact able to operate in a steady and smooth state, and this suggests that self-driving cars may be able to safely operate in the future.
I will be describing the limitations that I found in this article. So I decided while driving real life, many unexpected things happen. For example, another car swerving into your lane and you having to avoid that car in order to prevent a collision, or a pedestrian running in front of your car. The studies in this article did not take unexpected occurrences into account. The article explained that in order to study these unexpected occurrences that happen in real life traffic, the self-driving car model being studied must become more advanced first. I also found that in order to drive one of these self-driving vehicles, specific training was required, which limited the amount of people that could participate in these studies and that could drive this self-driving car to begin with. So those were the limitations, and here is the works cited. Thank you.